What's up, YouTube? All right, this is port 5 of this amp dyno, and it's coming along. The batteries were supposed to come today. As you can see, they're not there. UPS had a weather delay. I did run a 50 amp service for the Usina power supply. That little power supply runs Dyno, and this thing's pretty slick. It comes on, and it starts like in a low voltage mode, and it slowly ramps up so it doesn't shock your batteries or your car audio. And it has some different modes on there. It can do smart charging. It can auto sense the amp hours. It can also, I think, recondition batteries. It's showing the output, and of course it has a current meter right there. And also you can limit the current. And this thing will put out all the way to 500 amps. And it's the Usina Pro edition. Also, it shows the input voltage right there. And the problem with this thing, well, there's really no problem. It's all in Portuguese, and if you go to Usina's site, you can get the manual to it, but it's in Portuguese, and then you're gonna have to get some way to translate it. And I paid to translate it through one little site, and it comes out kind of hard to read. But it's pretty slick. That's where the output 14.4 volts is. It's lit up real nice. They got some nice little indicator LEDs. And this thing's pretty heavy, man. It's I think it's around 25 or 26 pounds. And you might be wondering what I have it mounted to. Well, that's a 3/8 inch piece of Delrin plastic. And if y'all don't know what Delrin is, look it up. That's some badass plastic. Of course, I got the rest of the dyno. The little wires I got just going to the voltmeter right there, and as you can see, 14.4, 14.4. Now, I was looking, I want a meter that has like min-max on it, and Basic Garage has one, but the problem with the Basic Garage one is it has a button on top, and I'm afraid it's gonna hit this. So AmpLab has one, a little OLED little meter like that, and the buttons are right on the front, and it'll fit right here. So I think I'm gonna get one of those coming to replace this little cheap Chinese thing. So I like to see the minimum voltage drop. Hopefully with the lithium's coming, you ain't gonna see much of a voltage drop, because I'll be running at least 2 runs of 4-aught. Really need to run like 3 minimum. I wish I had the money to run 4 for the positive and negative. And then I still got to get that wire. It's very expensive, even the Temco brand. And then I believe that's 2-aught maybe. I can make 2-aught work in there. But I want to run 2 runs of positive, 2 runs of negative down to the lithium bank. And I'll probably have 1 battery set up here and 1 battery set up here. I was trying to clean up some of the wiring because it was kind of looking bad under there. Didn't do too bad with the resistors though. That's all number 2. And you might be asking, why did I use number 2 for those resistors? Well, number 2 carries over 100 amps, and some of these amplifiers, high power ones, just put out tons of current. And when you have a distance from right here where you're going to test the amp to the actual resistive loads right there, you want very minimal voltage drop. Just like when you're running batteries and alternator to your amp's input power, you can still have a voltage drop to your loads. And if I could have put number 2 in that little box right there, I would have. It's got number 8 all in it. but they're such short runs, it shouldn't matter too much. So the power supply is on, and I also got this. This has 120 volts in it to power this, but also use the switch also to turn that little power supply on down there that powers the dyno, because I didn't feel like drilling and putting any more crap in this thing. Getting kind of lazy with it right now, so I just borrowed this switch and put an output on the back to go to that power supply, and it powers up the dyno. The dyno power is not on the batteries. It is on that little power supply with the green light. And I did that because I don't want this on the same battery bank. It doesn't need to be, really. Now this is going to be on the batteries and the power supply / charger. This meter right here, I still have not heard anything on my Chinese shunt. So what I did yesterday is I looked online and I contacted a company called Ram Meters Inc. And they're making me a shunt for this thing, custom made. And it takes a little while to get it made because they got to calibrate it. I can get a certification of calibration on it. And if it goes 0 to 100 at 2000, it's going to read right, because when I test this with my little process meter, it tracks pretty good. Yeah, I think it's pretty accurate. So, besides, y'all may be wondering, okay, where did I get this meter? Okay, this right here, this is a custom-made meter, and this thing was made back in 1996. I contacted Weschler. They still make these type meters, because I wanted a voltmeter like it with min-max on it that went 0 to 20 volts. I was going to put 2 of them in a box, but they gave me a quote of like almost $1,300 for a little 0 to 20 DC voltmeter, and I'm like, no, I'm not paying that. This one I found on eBay. I got really lucky. I was just looking for DC current meters. Somebody had this special made back in '96, and I believe it was on a motor or something, because it has M18 on the back, and they had some little stickers here where the thing, they had like a red sticker and a yellow sticker, I guess, when the current was getting too high. But I took it apart, the little cap, power supply cap and stuff still good in it. The only caveat with it is it runs on 120 volts, which is fine. And then you hook the shunt to it to read current. The shunt's going to go on the negative of the lithium bank. And what happens is the current flows through that shunt resistor. It makes a little voltage drop. And this thing's real sensitive. It measures that voltage drop and it converts it to current. It knows how much current's flowing through the negative side of the lithium battery bank. And this should be pretty accurate. Now, the only thing is, they didn't order this with a min-max. They had options for it. When I looked up the model number on the site, this one didn't come with it, because you have to build this thing. There's different codes you put together, like, and you can order it like that. Well, this one don't have it. So, I mean, for what it is, I think it'll be fine. We'll try to capture a peak current on the camera. It'd be real nice if you get up to clipping and it holds that max current when it drops back, when you turn the signal down. That would be real nice to go with a good voltmeter to find stuff like efficiency or whatever. So this thing, and sorry for the bright LEDs, works actually pretty good. Now I checked this with several meters. I have an Atlas LCR meter, and I was looking to see if there was any inductance. There is a tiny amount. It's like 5 microhenry, and when you do the inductive reactance formula at 40 hertz and 1000, it's still like 0.00 whatever ohms, so it's not gonna make a difference one way or another. And it's probably from mostly the wire. But the DC ohms, it was reading exactly 8, 4, and 2, and it would read 4, 2, and 1. So this little fluke here, it depends on if it's hot or cold in here, how it's going to behave. So sometimes it'll read right on, but I'll put it on there. So right now we are in mono mode, and this should be 4 ohms. And it reads 4.5 right now, but it's really cold in here. It's like 60 something degrees, and I notice this little meter is kind of sensitive to that. So when I go here, 2.6, and these are some little cheap Amazon leads on this thing too. Let me see if I'll get my other fluke and we'll try it. Let's see what we got here. Battery may be getting low in this thing. 1.2, 1.1. So it's pretty close. Let's go back here. Yeah, you see, just moving them little leads around. And this one right here, 4 right on the money. And then in stereo mode, we got 8.1. And then you're gonna have the same thing here, roughly. Let me get in there. 8 ohms. And then you should have 4 ohms. There's 4.2, 4.2. And then you should have 2 ohms here in stereo. And I only went down to 2 ohms in stereo because how many stereos, you know, run at 1 ohm per channel? So 2.2. It's probably actually more like 2. My little Atlas LCR meter is way more sensitive than this, and it reads right on the money. But how many watts does this thing handle? I'm sure some people have some questions about that. Okay, well, each resistor down there is 4 ohms, 5,000 watts. So if you think of each resistor as a subwoofer that can handle 5,000 watts, think about it this way. So on 4 ohm mode right here in stereo, I'm just reading 1 resistor. So you'll be able to dyno 5,000 watts. You can probably go over, you know, momentarily. You can probably overload the resistor for a short time till it starts getting really hot. But in 8 ohms, what it does is it puts, per channel, it puts 2 in series. So they're 5,000 watts, and whenever you put something in series like that, it still only handles 5,000 watts. You just increase the, you double the ohms. So 8 ohms, 5,000 watts. 4 ohms stereo, 5,000 watts. Now 2 ohm, it parallels them, and now because they're in parallel, it's like 2 5,000 watt subwoofers in parallel, they can handle 10,000. So in stereo mode, 2 ohms, you can handle 10,000. Okay. So in mono mode, you go to mono mode, what you're gonna have is 8 and 8. At 5,000, and it parallels them, so you can handle it's gonna make 4 ohms in parallel, but you get, because they're in parallel, you get twice the wattage. So now you got 10,000 at 4 ohms. Okay, and when this is in 4 ohms mode, you get 10,000 on that one too, because you have 1 resistor in parallel with another resistor. That'll give you 5 and 5 is 10. And then in 1 ohm mode, it parallels every damn last one of them. So 1 ohm can handle 20,000 watts. Can this thing do 20,000 watts? I don't know, maybe. I think these only go up to like 15,000. I doubt if we test any 20,000 watt amps in here, but definitely should have enough lithium to run one for a dyno test. These labels, y'all, I know they suck. They're all crookulated. So I ordered some more of this stuff for a little brother printer that we have. I'm gonna redo these and put it on a thinner little piece of plastic I can cut with scissors like I did these, because this is like some 1/8 ABS, man, and talk about a pain to cut, because just when I think I got it cut, man, it'll like mess up the edge or something like that, and then to cut it with like a little hacksaw or something is nearly impossible to do, for me anyway. I'm sure somebody out there can do it. So I talked to my friend who has a 3D printer. I'm gonna have a stand for the DD1, and I'm probably gonna get him to make another one for the MM1 in case we ever need it. Really, that AMM1, I can put it here and we can run it with this. It should work. Just we'll run the positive through it, come out, and then go into here, and it'll probably work okay for clipping light. And as you know, this thing is not going to read exactly what the AMM1 does, and there's many factors to that. For one, these have different circuitry, okay? They're using different parts with different specs that are close, and it may get you close, but I mean, if you're expecting from these little consumer products like this super accuracy, you're not gonna get that, man. You'll get pretty close. It'll give you a good idea what the amp puts out. So what if it's not super on the wattage accuracy? You need like some stuff built with like high-end parts that like mil spec and all like super low tolerance parts in here, because temperature can affect these things. And then the size wire you're using can make this read different. If you got one pickup like this on one part of the wire, and then you got the AMM1 closer to the amp, well, guess what? And you're running some little ass 10 or 12, 14, even some 8, you're running 50 or plus amps through that, you're gonna have a voltage drop. So you're gonna have less AC voltage at the other meter than you do at the meter closest to the amp. So there's lots of things, and I just try to mention that to another guy doing dynos on YouTube. I'm not gonna say his name, but he tried to talk to me like I was stupid, deleted my when I tried to defend myself on the comment. Well, of course he deletes it. Y'all can watch all that. He's a smart guy. I like what he's doing. I wasn't trying to be mean to him or anything, but I can tell right now he doesn't like criticism, and just be forewarned. You'll figure it out. Keep watching dynos, you'll figure out which one it is. Anyways, I wish him luck, and in the bass hit community, we should all, kind of have a little brotherhood with this stuff, and don't be a dick, So I wasn't trying to be a dick, and I don't know, maybe his things going on in his life, I don't know. Or maybe he just don't like criticism. Also, this thing I noticed is just a hair off. When I tighten it, I made the holes a little bit bigger on the 4 bolts here so I can kind of skew it. So I'm gonna have to take it, and I had it straight the other day, but when I took it apart and painted it, I had just kind of slapped it back together real quick. So other than batteries and a shit ton of expensive ass welding lead, I think we're almost there, y'all. That Unicina or Ucina, I don't know how you say it, Pro Edition 500 amp power supply. I really like that thing, man. It's pretty cool so far. I just got it on, I don't know, about 30-40 minutes ago. I finally was up in the attic running some number 6 wire to a 50 amp receptacle down there, and the cord on this thing was short. I had to cut off, I don't know, maybe 4 inches of that thing because it was trying to come up. So I just kind of cut it to length and plugged in. And got a breaker and all. I'll show you the breaker pan in here. Because I got a older house and it has like a 125 amp panel, and it had the old Federal Pacific, which is they're not good to have. Your insurance, most insurance won't even insure you. This is an old ancient panel, so I upgraded to this GE PowerMark Gold. It's all newer stuff. However, to fit this 50 amp, I had to put 2 tandems and pull 4 breakers, single poles, to get 2 slots for this. And if you notice, I put this thing right next to the main. And I did a low draw on all this with everything running, and we pulling, you know, without this figured in. The highest I've seen was about 14 kilowatts. So I think we're okay here. And none of the breakers really get hot anyway, not even the main. So that's that. And I got a BFM in here. And if you don't know what a BFM, I call it a big flucking mess to clean up, because I've been working on this all day. One other thing, I got the signal taps on back of here. I got this little scope, and these scopes are fine, okay? Like the little digital ones you get today, you know, they don't, some of them, they may be battery operated or whatever. I don't know if they earth ground or whatever, but you got to be careful when you test in certain amps, because the negatives on the amp output isn't always grounded, and it doesn't always like earth ground. So I got a isolation transformer. In fact, it's one I've been having, a big isolation transformer that I'm going to run with this, because I had a smaller little dummy load I test them tube amps with, and I would actually use that dummy load, I'm sorry, not dummy load, but the isolation transformer on my scope, just so it wouldn't mess with the amp. And it works fine. I'll have to put that thing down here somewhere, and this is a good little scope. I have a fancier scope. It's a HP, and it does peak hole and all that, but it's such a pain to use because it's all push buttons and stuff. It's an older one. It's got a big monochrome green CRT in it. I don't know, we may use that. This one's just very simple. It's just very simple, little 20 megahertz scope. And man, you can just, you know, zip with the settings. I'm used to using these back in the day. And man, we can see that clip on there if we need to, or we can always use the SMDA MM1 or both. So I think that's it for now. That's really all I can do. UPS said my batteries will be here tomorrow. If they're as impressive as I think they are, I may do another little update, and we'll figure out where we're gonna put them down here. They got some, may have to build me something. I don't want to put them on the concrete there, but I cleaned under there today, vacuum, swept, and I actually mopped that with some of that green Fabuloso, and man, did it smell good in here today. So, but I hope you guys been enjoying this so far. I like doing this. I've always wanted to build an amp dyno. Me and a friend of mine, he's got a channel also. We built an amp dyno back in the day with some, we went to the hardware store and we ohmed out a bunch of hot water heater elements, and we put them in like a bucket with some antifreeze in there, and we were testing like some old ass Orion amps and stuff. And but we didn't have no watt meters and something, and that was way before, you know, SMD had any of that stuff. That was probably early 2000s, and I've been thinking about having one since, I don't know, mid 90s. I always wanted to test power on amps to see what they really did. I could have bought a AD1, but I don't want to spend $7,000-8,000 on that thing. So it was kind of fun building my own, and I'd like to see how this works out, because if it does, y'all can build your own. I'll write up a schematic to it, and y'all welcome to build your own. Maybe make one way nicer than mine. I just want mine to work. So I was gonna call this thing the CAK 5000, and the CAK stand for Chinese Amp Killer. For all these little cheap Chinese amps, like them little Bose and the Power Acoustic or whatever. They probably no telling where they're made now. It's just somewhere over there, but we can load them up and torch them and probably kill them. So I thought that was a fitting name for that. So anyways, y'all have a great week, and just stay tuned for more. If I don't post one tomorrow, it means batteries didn't come. So I'll update when I get them, and take care.